and this is probably the most radical, done by Klaus Tom. It, in a way, is a super block. It's the big, these are all the same scale. This is big. But what they did is have a perimeter of bar buildings, and then, which is very rational, and then an inside which was like a piece of a medieval city. So you had this big block, and then this very medieval interior. That's because you had a fabulous view out here to Denmark and the Øresund Bridge. You had an inside and an outside, and then this thing here is the tallest residential building in Sweden. You'll see it in a second. These guys had blocks that were closed and slowly opened to the lake for views, alternating. So you had a street, block, park, water. You had an alternating system of open space. Very interesting. Here you had very high-density urban blocks coming down to quite low-density buildings at the agricultural edge. The most interesting thing about Robson is they had a spine down the middle, but they had finger blocks, which you'll see in a second. Block types. So here's the one I told you about, which is very harsh outside, beautiful views, a windbreaker, a medieval city on the inside. Here's what it looked like. This kind of thing on the inside, and then a high-density tower. If you look at Hammarby, you can see that they're open-ended blocks, creating views and views to the lake. They're basically 5 to 6 stories. If you look at the block types here in Kroonsburg, you have the higher density blocks. I just picked one here. I didn't pick these ones because they're fairly boring. But you have, these are passive solar ones, amazingly high performance. You can see a little neighborhood park with a school. And you can see one of these hybrid buildings that actually has the atrium down the middle, which is in here, which is another block. And then finally you can see these finger blocks at Hammarby, at Robson, where you can see the ends here. So each one of these ends has a little commercial store, but when you walk past it, you can get a view into the neighborhood. So it has an openness that's amazing. These are the first passive solar apartment building in Europe, uses zero energy, and this actually is a plus energy neighborhood on this side of the street. Green space. I'm not going to go into this in too great detail, but it's probably the most radical thing about these places. What to say? Every one of these projects required that you had to go to a public green space within 50 meters. Whether it was a small park or a green street. In Bowl 1, you can see all the green space here. What's amazing is they said every development piece had to have 50% of its total surfaces green. So that meant the courtyard, the facades, the roof, somehow you had that 50%. Very creative. In Hammarby, again, you can see all the green space here, all these different park types. An amazing place. Same with Kroonsburg, where you have a south park and a north park. As you can see here, green space and these amazing green streets that run through. And Robson, you can see these green fingers and then this amazing green spine down there. What about the energy? You all interested in this for a second? requirement for each of the buildings. Now, if you take goal 1, very interesting, the buildings, the measured performance of the building exceeded the goal by 50%, but was 50% or 25% less than the standard at the time. The interesting thing about goal 1 is they had a windmill down the coast creating electricity to run a heat pump that used the ocean and groundwater as its heat sink to provide heating and cooling. So you understand what's happening here. In the wintertime, you're heating, in the wintertime you're cooling the groundwater and the ocean water. And in the summer, you're heating it back up for the winter because you're taking heat in and out of it. Because they had such a great resource, even though they exceeded the goal, they were 100% renewable. So this is where when you have a great resource, you don't have to pay so much attention to your buildings. In Harrogate, no wind, very little sun. They were going to try to use waste. And they originally had a goal way down here. But the developer said, oh, it's too hard to do. If they had, they were going to try to get 50% of their energy out of waste. What happened is they exceeded it by the actual goal that they ended up with by 50%, and they got energy from waste this way. What's interesting about this is it's the first example in the world that I know of where waste has played a major role, even though it's only here at 23% of the total or something. So what do? They take all the combustible waste and they burn it and make electricity and hot water for heating. They take the sludge out of the sewage and they convert it to biogas for cooking and for vehicles. And they take the temperature that's in the sewage, run it through a heat exchanger so that they can take the heat out of it because it's much warmer than the environment. And they use that to help heat as well. So they're using all of these strategies from waste. And as you'll see, this ends up being, while small in total, it's a fairly big number. That's about 20%. If you take Kronsberg, we're now going from Sweden to Germany. They met the target. How did they do it? Very simple. You couldn't actually get a building permit until you proved through a energy simulation that you were going to meet the standard, this standard here. And you couldn't sell the unit until you'd done a blower door test to show that the air infiltration rate was as calculated. And you all know, if you're energy geeks, air infiltration is usually the most important indicator of performance. So they met this. They exceeded it by a little bit. And that's primarily because not too many people took the incentives to do high-performing appliances. And they had a very good system. They had 3 wind machines actually running a cogeneration plant that burned natural gas. They had natural gas available. So it's not 100% renewable, but it's very good. Now what about the coal line? So here you have all of these Baugrupens building their own buildings, learning from each other. They're building these things. The city's encouraging them. This is called learning while planning. So they have a wood chip cogeneration plant for the whole place. But they have lots of solar and lots of passive. This generates more energy for the neighborhood, 15% more than is the demand. And they actually beat the system. Their performance is below the target. And very, very close to 100% renewable. Okay. What about stormwater? It was a big feature in all these places. They collected it, treated it, retained it before it went back into the environment in Bowl 1, and it becomes a design feature. designers, you know, in most cases, cities just try to get the stormwater out of there. But here, they celebrate it. They celebrate how the downspout reaches the street and runs into a gutter. So when it rains, the whole environment changes. It becomes alive. It's acoustically interesting. Same in Hammerby. And these amazing bioswales in Chromesburg work fabulously well so that the actual stormwater runoff from this major development is practically zero along here. And then if you look at Beaumont, they took all the water, ran it to the middle, cleaned it in this space, and then put it back in the river over here. So they're really treating the stormwater as both a way of recharging the groundwater and also cleaning it and using it as a design feature. But they didn't reuse it locally. I think that would have been too radical at the time. So what about this waste potential? I really took a careful look at this in the book. So I wanted to show you this diagram. If you take the current standard in California, the Title 24 building, and you do all of the building efficiency, climate responsive architecture, in other words, ventilation, passive solar, shading, daylighting, etc., you can reduce the demand about 40 to 50%. Now, if you take, and this is hypothetical, as you'll see, I took EPA standards for solid waste from cities. So this is the glass, rubber, metal, plastic, paper, etc. And you recycle it. Take it back to industry, reuse it. But if you take some of the wood and paper, some of the yard waste, some of the food, and some of the sludge, and you combust some of it, and you make gas and combust that, you can make so much electricity and so much heating or cooling in a local district heating and cooling system. So look what you have left for renewables. It's a tiny amount. If you really are aggressive with energy efficiency, you could get the demand down to almost nothing. It represents one PV solar collector per person. That's pretty easy, right? You're not putting a big array on your roof. You can do it quite easily. And you don't have to oversize the system because these guys are giving you a good base load. So, while I'm writing the book, what should happen? One neighborhood in California, West Village, because a lot of the people who have been to those projects in Europe, they persuaded a developer to do this. They did all of the energy conservation shading systems, and they put solar on parking and on the buildings. And this is probably going to be the first net zero energy neighborhood in the U.S. And they did lots of other things. It's all bike circulation, all bus circulation, all bioswales to the streets. So they're putting the stormwater back into the ground. So what does this all mean? Now, how many of you are architects? And how many urban designers? How many landscape architects? Okay. So this is for the landscape architects, this is about you. Now, if we look at the history of urban design, and Patrick and I could tell you lots of tales about this. Most of these images are from Collage City, Colin Rowe and Fred Coe's book. And most of the design work was done using the figure ground as the analytical space that you operated in to create a formal spatial organization for the city. So that meant axes, balance, rotation, transparencies, all sorts of formal games were played. And this is an example of a figure ground. This is the Uffizi urban space like this, or you have an object like that. You can see the contrast between the old city and the modern city. But there's no question that for many years, urban design was taught as a formal spatial exercise. There's a long tradition, going back to Jane Jacobs, but more recently popularized by Jan Gehl in Denmark, where the public realm has space of social performance. And he emphasizes that the city starts with the life, the space, and then the buildings. And that we need to pay more attention to all of this than to these guys. And I think the lesson from my book is that we need to take a more profound and deep look at the urban section, which people started to do. Alan Jacobs and Elizabeth McDonald, who worked here in Vancouver, started to look at the urban section, the space for people and transit, as you can see, much more, in much greater detail than just leaving it over to the traffic engineers. But look at what's possible. I put this drawing of the thing that I showed you originally. The public realm has a huge role to play in terms of environmental performance. Yes, there is formal spatial performance. Yes, there is social performance, but look at these potentials. The public space can mitigate the microclimate, improve the air quality, absorb CO2, treat stormwater, treat wastewater, grow food, create habitat, create biomass for energy. And here are the ones that have been more typical. It's obviously been very decorative in cities. It has provided recreation and shared activity space from plazas to playing fields, social interaction spaces, and transportation. This has been written about by a lot of the landscape architects, but underemphasized recently. The health and well-being of cities that the urban landscape and the public realm engage is huge. So let's look at this for just a second. So you can draw 20 different street sections. This is a fairly typical one, some public transit, some vehicle traffic lanes, some parking, some bike lanes, sidewalks, shopping, mixed use, residential above. I grew up in an environment like that. I think there's a lot of this in Vancouver, right? Isn't this a fairly typical street? Especially as you get outside the main city. So, I'd like people to think about this section much more as a huge opportunity for being rethought. And let's look at some of the things. If you look at the ground, and what's the deep ground, just for a second. And I'm only doing this quickly. You can see the eco-functions. How the ground is as a surface and temper microclimate. It can absorb storm water, it can recharge groundwater, and it can be a carbon sink. When you have paved streets, paved everything, it's not a carbon sink. When you have something like this, it is. Now, who's done research on how much comfort in the public realm this can create, how much air conditioning it can save, how much it can alleviate the stormwater system, which in most cities, given the severity of our storms, are now way undersized, the improvement in health, and the senses. Imagine the smell differences and the sound differences that occur from all of this. Probably I don't have to, trees are probably the best investment a city can make. And it's wonderful to come back to Vancouver because just out here out of that lane. They are a hugely effective investment. Tempers the microclimate, stormwater absorption, air quality, carbon sink. If you take the clippings and use it in your wood chip neighborhood, those generations, even building materials can create. Enhances the comfort of the public realm, lowers AC costs, health impacts, energy value. How many people have put empirical numbers on this? Shouldn't we be doing this to show the city what an investment these things are and not a nuisance? What about these? Same sort of stuff. Tempers the microclimate. When you don't have the size of buildings way above the air temperature, it can really temper the microclimate. It absorbs carbon, improves the air quality, and also you can collect the biomass. Same kind of numbers here. And what's so interesting, if you look at this, the ground, the trees, and the facades, there was a study done at Arizona State. They took 16 blocks of downtown Phoenix, and they hypothetically changed the building materials of the ground, put green facades, added shade trees, and they simulated the environmental performance of that space. It lowered the average temperature by 8 to 10 degrees Fahrenheit, and the air conditioning savings paid for the improvement in the first 2 years. We need to do a lot more of this. You've all heard about green roofs. The same sort of story occurs. You can actually get some insulation value, and there's so many types of these things, depending upon the structure of the roof and the climate and what you're trying to achieve. But again, a lot of these values are not taken into account. You might get a little insulation savings. This is all seen as aesthetics. Maybe some stormwater. Now this I'm giving especially for Patrick. How many of you have been to Zurich and seen this? What did you think? Liked it?
Sorry, I've been to Zurich but I haven't seen it.
You haven't seen it?
Good question.
So this is the closest thing to a living green urban cathedral that I've ever seen. It is a superstructure, lightweight superstructure, where they planted a whole range of living materials to create space. And the reason why I show it is it's created a whole new way to experience the city. You can get up inside it. It makes a gathering room inside for events. It's an amazing place. I urge all of you to go see this. The interesting thing is these things don't have to just make a big rectangular gathering space. They can be used in the public realm to do all sorts of things. To shade, to protect against the wind, to actually cut off some of the air pollution from the streets. So I show you this because while this looks like an object, and is an object in some ways, its implication for the design of the section of cities is amazing. Obviously, urban agriculture in California would be a big deal. I don't know in Canada, your growing season is a little short, but with greenhouses you can make a big difference with them, especially if you take the wastewater and use living machines to clean it, you can now have water irrigate your agricultural production. In the eco-block, we calculated that 30% of the produce for the 10,000 people in that neighborhood could be grown in the courtyards as a result of recycling the water. Natural stormwater, you've all seen these. These are mainly from Portland. I would argue that they're using fairly traditional landscape elements start to have incentives for design guidelines for these facades to perform differently because they want to ensure that the heat island effect in the public realm is going to be under control. They can do the same thing with the roofs and the back areas and so on. So let me end with just this. So I think that the urban section is where all the action should be when we're doing design. It should relate to the food ground, of course, but it is the site of environmental performance. And that when we think about this, suddenly we have to ask, if we're going to recycle the water, where are we going to clean it? In the courtyards? Go back. Could we clean it in the courtyards? Could we even clean it in, say this was this part, say this is the sidewalk and this is the street, and this is the setback zone of a building. And this was the whole block. Could you treat all the sewage in this space? The answer is easily. But who's going to take care of it? How are you going to manage it? All of those questions get really, really interesting. So again, each surface can be rethought for a very new and specific role and create an entirely new design toolkit for urban design. Thank you very much.
Thank you very much, Harrison, and we have time for questions.
Yeah.
So,
Yes?
Yeah, it was a very interesting lecture, and I really enjoyed that. I learned so many things. My question is regarding the port cities, because an example shows that things are done. So when these cities were built in the 90s, was it like a policy like in China where they say they'll build it and people will come, or was it that sold already and then built?
Well,
How is it populated?
okay, great question. I skipped over that. I spent quite a bit of time in the book. It turns out if you take Bowl 1, it was a housing demonstration project for Sweden and for the EU at the turn of the century. It was actually supposed to be built by 2000, but they didn't finish it until 2001. So they wanted to show a whole new way of building and living in the city. So there was this kind of international demo. If you take Hammarby, it was part of a submission for the Olympics. And it was supposed to be another sample of a new kind of sustainable living. If you took Kronsberg, it was part of Kronsberg of Hanover's World's Fair, and also meant to be a demonstration. If you take Vauban, it's probably the most environmentally progressive city in the world. They have really high standards. The first completely self-sufficient house was built there. The majority of the city council are Green Party members. And so when they decided to convert an old French military corps into a neighborhood, they decided to really push it. And they went to people. They wanted, I mean, it's also the most affordable. So that was a more natural environmental grassroots effort, as opposed to the other ones, which were, civic and pride, trying to show off new ways of living. Now, the interesting thing is, they didn't get finished until just before we had the housing crash. And so it takes a long time. It takes 10 years to, conceive, design, plan, design, build, occupy, operate enough to get some performance data. So that's why they're relatively old. And why there's no stormwater reuse, there's no sewage treatment reuse. Although, except for one, Vauban, again, the most progressive, one of the little Baugrupens took all the sewage from their apartment building, made an anaerobic digester, used it to create power the cooking. They tried to do it in bowl 1, but the trouble was people were not really good about the organic material, so they'd stick glass and metals in there as well. So they had to sort it all out, so it didn't really work for digestion. So good question. Others, come on. Yeah.
Incinerating waste to create energy is a very topical subject in Vancouver now. There's some proposals to do that. Could you talk a little bit more in detail about some of the different ways that it's done? Is it just organic material that's incinerated, or is it kind of
Well,
other types of waste?
The process that I know about, which is basically a Swedish technology and a Danish technology, is they take anything that will burn and they preheat it with the heat of combustion, so it's very dry. And then they burn it in a very high performance, I guess you call it an oven, where they usually put in water particles to have really very, very good combustion. And then depending upon where they are, they have, in some cases, 6 to 8 scrubbing processes for the flue gases. And the argument is they like to do this rather than take all of this and put it in a landfill. They want to burn it to create hot heat for heating and electricity, and to collect the pollutants so that they can take care of them. So it's actually a pollution collection device, not just dumping it into the atmosphere. And that's the Swedes and the Danes and the Germans who care a lot about this. So if you have a good scrubbing process and a good way to gather those waste materials and take care of them, it's a very good process. Does that help?
Yeah, no, that's great. So they'll burn any kind of waste that's basically not recyclable.
Yep. So the interesting thing about green waste, if it's green and juicy, digest it. If it's dry like leaves, burn it. So, you can take the waste from the green environment and do two different things with it.
Well, here we separate all our waste. So we have, we have paper, we have plastics, recyclables, and then we have organics that we separate out. And then there's garbage, which is, non-recyclable, non-compostable garbage. Now,
That's solid waste. We call garbage the organic waste.
well, whatever. And that's the stuff I'm wondering about if you burn it.
You could burn it. As I said, in Sweden and Germany and in Denmark, I don't know that much about Finland, but they have really good technologies, and practically the district heating system for most of Stockholm is combustible waste. For a big portion is. Yeah.
In a way, you're talking about a circular economy. And I think by definition, waste is inefficiency. In the circular economy, you're trying to achieve maximum efficiency.
Right.
I'm going to go to the other question's point, because here in Metro Vancouver, we're talking about building a waste energy gasification plant. It's very controversial. But when you look at some of those plants, for example, in Copenhagen, they're having to, those plants have a fixed size. And they have that fixed size in order to be efficient. As you begin to reduce the amount of waste that you're generating, you run into the problem that Denmark is trying to deal with now. They're having to import garbage from Germany in order to keep this monster at capacity, because you can't reduce the capacity. It is a fixed process. How do you respond to that? And is the issue there what you started with, which is
The big utility problem and the scale problem. Yes, it totally is. So, the answer, I think, to that, again, it's a detailed engineering question, would be to build these in a modular way. And then the question becomes, what is the lowest module that you can operate at to do this? So let me tell you what we're doing in Berkeley right now. Most of you probably, if you grew up in this area, have blocks that have maybe 30 single-family houses, maybe some shops on the corners and the ends, right? It's a typical streetcar neighborhood block model for most of Greater Vancouver. The same is true of Berkeley, the same is true of Oakland, the same is true of a huge number of cities in North America. So we're going to take one of those blocks, we're going to open up a shared utility corridor down the middle, and we're going to collect all the garbage and all the sewage, and we're going to have community solar on the roofs, and we're going to see if we can make the system operate economically at the scale of roughly 30 to 40 homes. And we don't know if it's going to work. It's a pilot project. We're then going to try it in a more urban block that has closer to 200 to 300 units to see if we can find the space and optimize the systems to operate there. Then you would have a reproducible, scalable model that could really be rolled out. So you've asked the right question. It's a question of scale. Obviously, in the biogas generation, the bigger the system, the more cost-effective it is. The question, though, is once you get it big, then you have to redistribute it. So there are advantages to keeping it, say, within a block, because then you don't have to run it across the street to another place. So that's why we're going to look at the block scale. Then we'll look at the district. Maybe there's some water things that are better done at the district scale. And then the question becomes, how much do you want to rely on the existing infrastructure, and how much do you want to become independent from? It's going to be some hybrid system. In any case, you need urban landscape to play a role. Because you've got to find space to do this, but you want to make the space actually add to the quality of the neighborhoods. The best thing about those neighborhoods is that people love them. Some of them knew that they were really, really energy efficient, but they loved the fact that they were in a urban density situation where the green environment was much more dominant. And it was really valued by those folks. So it became an object of desire, not a sort of pill you had to take because we needed to be more sustainable.
So all of these neighborhoods have been extremely successful?
Incredibly successful. In fact, I probably shouldn't say this, but the planner for Bowl 1, the city made so much money in that project that they were able to keep going with the later phases, and they had to hide how much money was made as horizontal developers. But by the way, you urban historians, from roughly 1860 to about the end of the Second World War, most of the cities in North America, including Canada, the city was the horizontal development. They designed the streets. In some cases, they put in the transit. They planned the parks. They put in all the utilities. And then they sold the plots to builders for the vertical housing or offices or a church or a school or whatever. And that's how we built our cities. It was an amazing city building era. After the Second World War, there was so much expansion, at least in the U.S., that they gave away everything to the developers. And the cities gave up, I think, one very, very important and powerful tool which they should take back. And I don't know the history of Canada, but I would think having the city be the horizontal developer that can demand the integration, that can have a sense of a greater good, not developers who want to build the least amount of infrastructure, the least amount of roads, the least amount of everything, because at that point, they're really trying to make, maximize their profit. Yeah?
Thank you for the presentation. The examples that you use in the book are fascinating. A lot of them are what you're design gives them constantly as a model. And you've compared them really good. It's very helpful. But you touched on one area which I think is going there with your last comment, which I think is absolutely critical to delivering these kinds of communities, and that's governance. And certainly the governance for most cities is quite different in terms of facilitating these kinds of development. Could you talk about any municipalities that you come across in the States, for instance, that might be getting close, that might be making this kind of breakthrough? It's such an important part of it, especially.
So, I guess that's, as a preface, I should say, it's pretty clear when you see these things, although we as designers can be really excited about all the physical design potential that, the public realm and the urban landscape and all the surfaces can create. And I think we have only scratched the surface. The real problem is the financing and the governance and management of these things. It's as important a design problem as the actual physical elements. And, this is where we really need to have tremendous collaboration within the schools to explore what some of these creative financing and governance models could be, as well as really good participation with the cities. What would be okay for them to do? What would they be interested in trying and experimenting with? Now, if you look at Portland, it's probably the most progressive in the United States that I know of. And I haven't spent enough time there to really understand how they've done all the financing. But they're essentially taking money that would have been required to redo the sewer systems, to do a stormwater system that alleviates the problems of undersizing with the stormwater system. So they're doing some kind of hybrid. And they've been able to get